All right, so let's go through some examples of an ANOVA in R. So for this data, we're going to be looking at an example of some made-up clinical trial data where we compare a control condition to a couple different drug conditions to see what drugs seem to be effective in changing the outcomes. So first thing I'm going to do is I'm going to load up one of those example data sets that we have that came with the textbook, which is the clinical trial.r data. So I've used this in a couple examples before, so some of this might be familiar. So there's this clinical trial data here. There is the drug, placebo, anxiety-free, joyzepam, as you see. And then there's how much the mood changed. So we don't actually need to hold on to that. That's just to take a quick look at it. And we can print this out in the console too and look at all of this data. And you see for drug, there are actually 3 conditions here. So if we want to look at all of those at the same time, we wouldn't be able to just do a t-test, which is now we're switching to analysis of variance. So the first thing that we're going to want to do is that we're going to create a table for that clinical trial data. And that's so that we can compare those 3 groups, because right now it's saved under that variable with it being 3 groups, and we want it set up as a table, kind of like what we did for the chi-square analyses a couple weeks ago. So I'm going to make a crosstabs with the drug in the clinical trial data. So this is going to make a table out of that variable drug. And so this will run, and this tells you that there is 6 in each of those conditions. There's 18 participants total. So what we're going to want to do is aggregate that data, and we want to get the means and the standard deviations for each of those 3 groups. So that's the first thing we're going to do here. First one's going to give us means. Second one's going to give us standard deviations. And so if you look here, you can see at a glance that the mood gain is about 0.45 for placebo, 0.72 for anxiety-free, and 1.48 for joyzepam. So just looking at the means, it looks like it's higher for joyzepam. For the standard deviations, you're seeing it's somewhere around the 0.2, 0.3, 0.4 range, so maybe those aren't completely equal. We'll get back to that and see if that matters, that there seems to be differences in those standard deviations. So to get a sense of this, it's a good idea to look at the means for the groups just to see it visually. When you're just looking at the numbers and the standard deviations, it's a little bit harder to make sense of. So this is good for making sense of your data. And also in papers, it's often used that you put the results of an ANOVA in a table with those means and standard deviations, or even, fancier plots so that people can visually see, what do things look like in the different conditions. So you would want to install gplots, but I'm pretty sure I have that already installed. So I'm just going to run this here and check to make sure that that ran correctly. So it did, good. And now I'm going to plot these means. I'm going to move this over a little bit to make sure that the table actually shows up over there. So when we run this, and I mean, this always looks pretty ugly when you don't mess with it much, but you can see here that you have placebo, anxiety-free, joyzepam. Again, it looks like the mood is better for joyzepam down here for anxiety-free and placebo. And you also see that there's these bars that are at a standard deviation above and a standard deviation below that mean. So this kind of gives you a sense of the range. So these two, again, seem to overlap a decent amount here. This one seems to be up there by itself, even when you look at how much variability there is within that group. And that's important because remember, when we're looking at an ANOVA, what we're interested in is what is the variability between groups and what is the variability within groups. All right, so again, that's just kind of a quick way to look at it. Next thing we're going to do then is we're going to jump into actually calculating that out. So the next part of the textbook goes in some detail about the theory behind analysis of variance and some of the mathematical functions behind it. Again, we're going to be running through that in R rather than be doing the actual calculations, but it might be good to just go through that to kind of confirm for yourself. Here's the background behind where all of those calculations are coming from. So I'm going to go through breaking down that analysis in R rather than doing it by hand. All right, so what we're going to be doing is we're going to be comparing the group means. So for this, we are calculating the sum of squares. And so this is squared deviations from the mean for each group. So we're going to create a variable called outcome. And so our outcome here is the mood gain. So this is ranging from 0 to up around 2 for these variables. So we're creating this variable, and then the group is the grouping variable drug. So there's 3 separate groups of drugs that we're looking at. A placebo as compared to 2 other drugs. So for this, we are creating a variable called gp.means. Again, you could call those whatever you wanted to, but this is just kind of useful names. So for the group means, you're going to get a table that is going to combine this data so that you have the outcome, which is mood gain, you have the group, which is the drug, and you have the mean as well. So we're basically combining all of this together. All right, so then for this, the group means will have GP means in reference to group. So running all of this, just confirming that this is all running correctly. And then what you're going to be calculating here is the deviation from each of the group means. And so what this is doing is it's taking the value for each of those 18 data points. Remember, there's 3 groups and 6 data points within each of those groups, and you're figuring out how far each individual score is from the group mean. So this is the absolute deviation score for each of those data points. So we run this, and then we're going to use the squared deviation, which is basically taking this thing and squaring it. So that's a bunch of steps to go through that individually, but basically what you're doing is you're saying, okay, for each data point, what group are they in, what is the mean, and how far are they away from it? So if there's a data point that's here, we're subtracting that value from that mean and getting for each participant, how far are they from their group mean? And so with that, we're able to calculate out the sum of squares for that. Then what we're going to be doing here is that we're going to be creating a data frame. Again, a data frame is where you have a list of variables that you're combining together. Just calling this Y, pretty boring name. You're seeing in the data frame, we're grabbing all of this information and saving it. And you have here the group, the outcome, so the dependent variable that we're looking at, group means, the group deviations from the mean, and squared deviations from the mean. So these are all mathematical inputs that we need to do that f-test. So we'll go ahead and run this function, and then we will actually print out this function, and we're going to have it rounded to 2 digits after the decimal point. So what you'll see here is now we've converted this into what R can use to do the long version of what you do in an analysis of variance. So you see, for example, for participant 1, their score is 0.5, but the mean for that placebo group is 0.45. And what you find is that the deviation from the group mean is subtracting 0.5 by 0.45 to get 0.050. So it's just doing the math for you for each of those points. and then it's squaring that. So you're getting all of the squared deviation scores over here. And it's doing that for each of those. And you'll see for all the other placebos, it's taking it and subtracting 0.45 from each of those. So the next thing that you want to do is you want to be calculating the sum of squares. And for this, we're doing the sum of squares within. And this is what we've started out with, because this is how much that individual score deviates from the mean for that individual group. So for all of the ones in here, it's how much it deviates from that point. For all the ones in here, it's how much it deviates from that point. So it's in comparison to different means for each of those three groups, which is important because that's one part of the variance. So let's create sum of squares within, which is a sum of the squared deviations, which is all of these things. And then if we print that out, this is what we get. So that adds up to 1.39. If you wanted to do that by hand, it's basically just adding up all 18 of these points. So this is basically telling you how much deviation is there from each of the three group means if you add up all of those scores together for the three groups. So then the other part of the variance is the sum of squares between. So this is the difference among all of those three group means. So for this, we're using the group means, which has you look at the outcome and splits it by the group, and then you're getting the mean for that group. So we run that, and then we compare that to the grand mean, which is the overall mean for all three groups combined. Then what you're doing is you're seeing how much deviation there is from the grand mean. And what this is doing is it's taking each group mean and subtracting it from the grand mean. So just eyeballing it, it looked like the grand mean would be somewhere around here, maybe right around 1. And so you're going to get 3 different deviations from that for each of those 3 groups. And then the deviation from the grand mean, I think I ran that twice, but deviation from grand mean is doing that. And then again, we are squaring all of those deviations for the sum of squares between as well. Then you're taking the group size into account. And here you're looking at how many participants are in each group. So the length is how many participants are in each group. So this will give you a sense of the squared deviations that are between groups here. And so now we're creating a data frame where we're adding in some more data here. So you have the Y data frame, and you're now putting in the group mean, grand mean, deviation, square deviation, and now you have the additional information that's going to help us figure out the sum of squares between. So let's run this, and we will print this now out, and we've added a few extra things to the data frame. We have this printed out here. And what you see here is that you have the group means for each of the 3 groups for the ANOVA, placebo, INCSI-free, joyzepam. You also have the grand mean that this is being compared to. And when you get the deviations from the grand mean, this is telling you the difference between these two, essentially. And then if you square that, this gives you the squared deviations. So this is 0.188. Here you have the group size. This tells you that there are 6 participants for the placebo. And this is the weighted squared deviation, which takes into account that there are 6 values for that squared deviation. Right, and so this is going to be the basis for figuring out that sum of squares between. So for this, we are running sum of squares between, which sums up all of the weighted squared deviations, and we are going to print sum of squares between. So that gives us a value of 3.4533. So what this tells us is that this is how much variance there is within groups, and this is how much variance there is between groups. So the author notes that there's going to be slightly different calculations from how this works in the textbook if you're comparing to that, because hand calculations are going to rely on rounding errors, which is why you don't want to have these things done by hand. With R, it's putting it out to many decimal places in the calculations. And so it's much more precise than doing it by hand. So, so with this, how it used to be done back in the day is that if you were doing all these hand calculations, you'd then pull out a big book that had, okay, if you have sum of squares between, sum of squares within this many degrees of freedom, this is what you get for a p-value. So there is this function, pf, which is the p for an f value, which is formatted such that you are able to put in the inputs, and what you'll get is an F score of 18.6 based on, again, the sum of squares within and the sum of squares between that we had down here, 3.45, 3333, 1.391667, and also adding in the degrees of freedom for both between and within variance. And then you have 18.6 for the F, degrees of freedom is 2 for the between, and degrees of freedom is 15 for the within. And you say lower tail equals false because it's always a one-tailed test for an F. So when we run that, we've put in a lot of work to get this p-value at the end. And this will give you 8.672727, but you have to move over the decimal place 5 points here. So this is like 0.00008. And so that is less than 0.05. And so for that, if we were using a 0.05 for the alpha level, we would conclude that there is a significant difference in mood gain among the 3 different drug groups, placebo, anxiety-free, and joyzepam. So again, that is the super long way to do it in R if you're doing everything manually. In the next video, we'll go over how to use the actual analysis of variance functions in R.